Okay, hello everyone. I hope everyone is doing fine. So, what's the date today? 25th of November, and we have this lesson 3 of our 3D geometry. I have completed 2 lessons, and I hope everyone has seen that. And if you have not seen that, then okay, watch it later on. I'll put it in the description box, and you can watch it then. And today we have this lesson 3 of 3D geometry. So I hope everyone has come and we can get started by now. It's 5 p.m. sharp. So basically, okay, first of all, I would like to ask all of you to rate the quality of our podcast out of 10, which is 1 for the worst and 10 for the best. So anyone can rate us and you can put it on comments and I can read it out so I could understand and what is the problem and how is everyone going and how is everyone perceiving us. So anyone who would like to tell us that how is the quality of our broadcast going, kindly let us know in the comment section. Today is the lesson 3 of a 3D geometry. Okay. How is the preparation of your exam? Okay, I hope it's not bad. I hope it's best, but I know most of you must be in the second level, so they're not on the best level. But I wish that you get to this best level very soon and you can rock in your JEE. Okay, 10 10. So we have this 1, 2, 3. So anyone who would like to tell us is how is your preparation going, they can tell us in the comment section 1, 2, 3. 3 for the best and 1 for not good. Okay. So let's move to the next slide. So mathematics subject about me. So I am an engineer by the choice, and I have this interest in mathematics. I have chosen software development, so my interest will be in software development. But from the childhood, I love maths. I love to do maths. My favorite subject was maths. So that is why right now I am here teaching you all guys maths. So what is my aim? It is to provoke the I know the text is now do. I think there has been some problem in the PPT thing. So I'll put it in a good way next time. I'll read it out so that you can understand that what is the aim? We aim to provoke the thought process and break all the barriers which stop me from growing every day. And I hope the same for you, that you break all the barriers which stops you from growing every day. For anything which is stopping you from growing, you should just remove it and you should just focus on your growth. Okay. So I hope everyone is doing fine. And moving to the next slide. So we have this course which is providing us 90 plus classes, convenient education platform, and we have the syllabus for JEE experts. Also, so basically you will get a mentorship of 1-to-1. Okay, I'll help you out. I'll strategize your JEE preparation. All of you guys need to do hard work, but we will make you do the smart work. We'll strategize your preparation and we'll help you crack the JEE exam. And I very well wish that you all will study like that in that pattern, and it will help you out in the best way. Okay. So how our classes look like? So this is basically the flipped classroom method, which is basically telling us we give us the theory and study material first, then we'll start the webinar, and then we'll do the homework thing, and then there will be a homework check. So basically the theory and study material, when you will see the study material, you will get to know that what you actually don't know and what you will get to know. So basically it will create curiosity in your mind, and that webinar will satisfy all your curiosity, it will answer all your curiosity, and that will make you memorize things more and more. And after that, when you do the homework, then you will recall the webinar, and that will make you memorize everything, and it will make clear all the topics. Okay, so this is basically the flipped classroom method, and we have adopted this. So this method is basically used in very high rated universities in India, also in IIT Delhi it is used. So we'll use it, and I hope you will also use it, and make sure we bring up the best results together. So this is the subscription plan. So you guys can choose whatever the plan that suits you. It is basically divided into 3 parts, that is light, smart, and proficient. Okay. So this is basically all the things which you will be provided. And okay, I hope everyone gets to know about it. So we have this lesson 3 of 3D geometry. So what is studying today? The angle between two lines, the foot of perpendicular and image of point. So this will be our goal, the angle between two lines, the foot of perpendicular and image of point. I'll try to cover all the three topics, and in case if we could not cover the image of point, then we'll cover it later. So angle between two lines, first we'll start with, and then we'll move to the foot of perpendicular. This is basically very conceptual, no formula is used here. And an image of point, that is also conceptual. If you will understand the foot of perpendicular, that is basically the base of the image of point thing, because it basically use kind of the concept thing. Okay. Also, scan this code to get yourself added to our Telegram channel, which is Altedemy JEE. So basically, you will be providing PDF materials there for everyone who needs PDF. For everyone who asks me that provide us for the PDF, then you will be provided PDF there. You will be notified about all the announcements. You will be notified about discounts as well as the prices and all the free classes. Okay. Also, we have this giveaway for everyone who is added to our Telegram channel. Out of them, some people will be selected and they will be given the giveaway. So wish you all the best for that. So now, without any further delay, let's start with this angle between lines. So angle between lines, I'll read it out first. The angle between two lines can be found in 3D space using dot product of vectors. Okay. So what do you do in 2D geometry? You guys remember angle between two lines? You used to do tan theta thing. Okay. Let me do it. Let me write it first. Slide thing. So we have this angle between two lines in this 3D geometry, and what you used to do in 2D? Anyone? If any one of you remember, what you used to do in 2D? Okay. So what you used to do in 2D? Used to use this tan theta format. Okay. I hope everyone remembers it. We used to find out the slope. We also used that M1 M2 formula. Okay, that was basically in the 2D thing. So now we are in 3D. So what we will use is dot product of vectors. Every one of you must have studied in this in physics. What will be the angle between these two vectors? We will use this cos theta thing. So considering these two vectors B and D, and then the acute angle theta between two straight lines is given by. So this will be the vector B, this will be the vector D, and it is the angle theta. So basically theta will be B dot D upon, so basically cos theta is equals to the dot product of vector B and vector D. Okay, and then we'll divide it by the magnitude. Okay, divided by the magnitude of these two vectors. So basically this will give us the angle between the lines. Okay. So now we have where B and D are considered as the direction vectors of the two lines as shown below. So basically these are the direction vectors. Okay. Okay. Now let's move to the next slide. Also subscribe to the channel right now. Okay. It is free of cost and we post regular classes. So I hope everyone, and also switch on the bell icon. Okay. So that you get notified about our classes. We put on the reminders thing about the webinars. So that is going to help you. It will schedule your day and you can make out time for that. So subscribe to the channel and also like the video, and also use that bell icon to get notified. Okay. Okay, and I hope everyone of you are subscribed it right now. So we have this cos theta thing. So R is equals to, I'll write it down because we don't have these symbols. Cos theta, that is basically the angle which we are talking about, the angle between the lines. Okay. So okay, so we have this vector R is equals to A plus lambda B1, and we have this vector S is equals to D plus lambda B2. Okay, now we have these two vectors R and S, and now we have to find out the angle between them. Then first of all, I have already told you what is A and D. A and D are basically the points which are lying on these vectors. Okay, we have this B1 and B2 vectors which are the direction vectors of R and S. So direction vector will help us to find the angle, right? Because A and D is just the point on that vector. It does not play any role in the direction thing. B1 and B2 are the direction thing. So what will be the cos theta? It will basically B1 dot B2 under root B1 let me not write it in this way. B1, it's a magnitude, and B2. Okay, so this is going to be the angle between them, B1 dot B2 and upon B1 dot B2. Okay, this is the dot product of B1 and B2, and B1 and B2 dividing by the magnitude. So basically this will give us the cos theta value, and when we have cos theta, if it is asked cos theta, then you can just return the answer, and if it is asked the theta, then you can just inverse it, like cos inverse. Okay, so what you will do is theta is equals to cos inverse B1 dot B2. Okay, so this will give us the answer, and this will solve the question. Okay, it solved the purpose. And okay, now this is the question. Okay, now we have this question: find the angle between the pair of lines given by r is equals to 3i plus 2j minus 4k plus lambda r is equals to. Okay, now we have this question. Don't see the solution. Okay, I have just written the solution in a perfect way, because when I write it, some of you may not have understood the writing. Okay, so that is why I have put the solution like that, but don't see it right now. Try to solve it on your own and then see this. Okay, so what we have is, okay, so what we have is here, this is the vector, this is the point which is lying on that vector, and this is the direction vector. This is the point and this is the direction vector across r and across r. Now we have angle between them. So what we are going to do is, we are going to do the dot product of these vectors. Okay, because these are the direction vectors. In the cos theta, when I told you for the first time, there also it was written direction vectors. Okay, and then we'll just divide it by the magnitude. Okay, we'll only use this b1 b2. We're not going to use this, does not have any role in the cos theta thing. Okay, I've written this in the theory also. See here, it is written b and d are considered as the direction vectors. Okay, so these are the direction vectors, and b dot d, so we have used in the formula the direction vectors only. So in the question also we use the same thing and we solve the purpose. So this will be dot product of these. Okay, I 3i. Okay, what is going to be 3 2 2 4 2 6 12. Okay, this will be the dot product, right? What will be the magnitude? I 2j 2k. So what will the magnitude? 1 square plus 2 square plus 2 square. What will the magnitude of this vector? 3 square plus 2 square plus 6 square. Okay, what we get here? 3 plus 4, that is 7. 7 plus 12. So we have this thing, 12 plus 4 16, and then we have this 3 which will give us 19. So what we have is 4 4 8 9 under root 9. What we have here is 36 plus 4 40, 40 plus 9 49. Okay, now we have 19 upon 3 into 7. Okay, so here we get theta is equals to, so what do we get? Theta is equals to cos inverse 19 upon 21. Okay, this will be our answer. I hope everyone has understood this, and can we go through the solution once? Just read it out once. Just look at it if you could not solve on your own. So basically this will solve the purpose. So it was not a very big deal. We just did the dot product between the direction vectors. We just divided by the magnitude of those direction vectors. Okay, and that was the formula, cos theta is equals to, and that will be in a mod. Okay, so we have this b1 dot b2, and this is okay. So this we have done. Now we'll move to the next slide. Okay, here we have another question, because I just noticed that in the previous classes we did a lot of theory, but we could not do the questions. I made the PDF form of PDF, but I did not posted it, and you could not solve so many questions. So in this slide we have questions a lot instead of theory. Okay, I hope everyone of you enjoyed, and if you find any problem in it, and if you want the pattern to be changed, if you want some changes on it, then you can just write it out in the comments. Okay, we'll read it and we'll consider it, and we'll make some changes according to it. It will help me also, and obviously I want the best results. Okay, I want you to understand completely, and I want myself also to put my efforts in a correct way. So if any one of you faces any issue, if any one of you wants any change, then you can just write it in comment section, and I will read it and I'll consider it, and I'll make the changes accordingly. Okay, so we have this line now. Find the equation of the line which passes through the point 2, 1 and is parallel. Okay, this is a 2D question. Okay, it is just for the division purpose, so that you can just take a look back on the 2D geometry, and it will help you in the 3D geometry as well. So what it is written here, and is parallel. So we have this point. For equation of line, what you need to know, a point and a slope. Okay, if you have 2-point thing, then you just need to know 2-point form. For 1-point thing, you just need to know 1 point and 1 slope thing. So for any line which is parallel to another line, the slope is always equal. I hope every one of you knows this, that for parallel lines, slope is equal. Slope is same. Okay, so we have this x plus 2y minus 4 is equals to 0. We'll convert it into y is equals to mx plus c form, where m is the slope, c is the intercept. I hope everyone knows it. So 2y is equals to minus x plus 4, y is equals to minus 1 by 2x plus 2. Okay, so we have this slope which is m is equals to minus 1 by 2, and now we have this line which is 2, 1. So what we can do is y is equals to mx plus c. Okay, we can substitute the point as well as the slope, and we'll get the c thing. Then we can just write it in this format. So what we will do is we'll substitute 2 is equals to minus 1 by 2, 1 plus c. What we did is use this point and use this slope for it. Okay, we'll get the value of c here. So what is the value of c? The value of c is 2 plus 1 by 2, that is 5 by 2. Okay, now what will be the equation? Y is equals to minus 1 by 2 x plus 5 by 2. Okay, so that can be also written as 2y is equals to minus x plus 5. Also it can be written as x plus 2y minus 5 is equals to 0. This will be the equation of a line, and I hope everyone knows it already, and for those who don't know, they just got to know. Okay, so what we did is we knew the format y is equals to mx plus c. We found out the slope because for the parallel lines the slope is same, whereas for the perpendicular lines, you know, m1 into m2 is equals to minus 1. So everyone knows it. For the perpendicular format, what we could do, for the parallel lines we just use the same slope. So for the parallel line, we found out the slope by the format y is equals to mx plus c. We found out m, and then we have that point, we have that m. We substituted in the format y is equals to mx plus c. We got the value of c, and then we just put it in the equation, which is y is equals to mx plus c, and that just gave us the answer, which is x plus 2y minus 5 is equals to 0. I hope everyone has understood this, and it has already been taught in the previous classes of yours. So I hope everyone knows about it. Okay, now we have this angle between the lines whose DRs are A1, B1, C1 and A2, B2, C2. So for anyone who does not know what is DR, then actually I have already told you about the DRs and DCs in a very vivid way. Okay, I have taken one whole class for that DRs and DCs, and also did a lot of questions there. So for any one of you who has not known about the DRs and DC, you need to look at it, and it's going to be very helpful for you. So I hope every one of you will study from that, and they'll get to know about this DRs and DCs. So for okay, I'll just give a recap that DRs are basically direction ratios and DCs is basically direction cosines. So direction ratios, what I told you was that direction ratios can be infinite, okay, because ratio is something which can be simplified and it can be multiplied and it cannot be unique, but for the direction cosines it will be unique. So I hope every one of you knows about it, and for because we are studying the angle between the two lines, so we'll do this. So I'll just put it in the format. I know many of you, I have already told about it, I guess, in the previous class, but I'll just, because we are talking about the angle between the lines and our topic is angle between the lines today, so I'll also write the formula of it. So what will be the angle between the lines? So let's suppose the angle between the lines is theta. So the formula will be cos theta is equals to same thing, okay, a1 a2 dot product of these b2 c1 c2 a1 square plus b1 square plus c1 square a2 square plus b2 square plus c2 square. Okay, so this will give us the answer, which is cos theta. Okay, so we all know the vector in this line is a1 I cap, b1 I j cap, c1 k cap. Same thing, dot product of the vector and dividing it by the magnitude. So it is giving us the same result, and that was the formula, right? What was the formula which I told you first? That was the formula, right? So this is basically the same thing, dot product and dividing it by the magnitude. Now if two lines are parallel, I just like in the 2D thing I told you, same goes for the 3D. Okay, so I'll just write there the condition so that you can just visualize things. You can just imagine this image when you will do the question. It will help you all. So if two lines are parallel, then what? We're talking about the DRs, right? So we have this A1 upon we have this a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. This is the condition when the two lines are parallel. Okay. Now, what is the condition for perpendicular? For everyone knows perpendicular lines, cos theta will be 0. Okay. So, what will be the condition here? It will be a1, a2 plus b1, b2 plus c1 c2 is equals to 0. That will be the condition for the perpendicular lines. Okay, so this is going to be the condition for the perpendicular lines, and this is going to be the condition for the parallel lines, where I'll just write it, a1 b1 c1 a2 b2 c2, these are the DRs. Okay, of the two lines, and this is the condition for the parallel lines, and this is the condition for the perpendicular lines. Okay, you can take a screenshot, you can pause it, and you can understand it, because it's going to be used in many questions basically. Okay, every line is parallel or perpendicular, one or the other question. So now we have this question. Find the angle between the lines r is equals to 2i cap plus 3j cap plus 4k cap plus lambda. Okay, it's a little cropped, so I'll just write it here. We have this vector r is equals to 2i cap plus 3j cap plus 4k cap plus lambda I cap plus j cap, and we have this vector 2 r is equals to I cap plus 2j cap minus k cap plus lambda I cap minus j cap minus k cap. So this is the same question. We have this whole vector, but is it going to be used? Is this part, is this going to be used? No, this is not going to be used, because I have already told you this is just a point which is lying on that vector, whereas this is the vector. This is the vector which is parallel to this vector. So this will be used because this is in the same direction. The parallel vector are the same in direction, right? So this is the parallel vector, and we will use this vector for finding out the angle. So what is the formula of us? That is cos theta is equals to b1 dot b2, the dot product, and then dividing it by the magnitude. Okay, so what will be the dot product of it? 1 minus 1. Okay, now we just got 0. Okay, so everyone knows cos theta is equals to 0, then theta is equals to 90 degree. But again, like just dividing it by the magnitude, it does not need it. Anyways, so cos theta is equals to 0. We got this, and we know cos theta is equals to 0. What does it mean? It means theta is equals to 90 degree. Okay, everyone knows theta is equals to 90 degree when cos theta is equals to 0. Okay. I hope everyone is enjoying the session and understanding it. If any one of you is facing any issue, you can write it in the comment section. I can read it out and I can understand what is the problem going on. Okay. Okay, so now we have this next slide, please. So now we have this find the equation of y-axis. So for anyone who would want to answer this question. So for in the 2D geometry is very easy. X is equals to 0. Y-axis is no. 3D geometry we have different things. Okay. So you need to know about the equation y-axis, x-axis, z-axis. It's like kind of same thing. So if you will do one question, you'll get to know about the other two as well. Okay. So here you will talk about the y-axis, and you cannot just write x equals to 0. No. You're not that smart enough. Now, let us start the question. Find the equation of y-axis. So here, what we can use is, the dr's thing. Okay. So we have these two known points. Okay. I'll tell you how we have this. One is the origin. Okay. Origin is common for everyone. So we have this origin 0, 0. And now we have this equation of y-axis. Okay, so we have 0, 1, 0. So we have these two known points. Origin will be common, and for x-axis it will be 1, 0, 0. For y-axis it is 0, 1, 0. Okay, and same goes for the z-axis. It will be 0, 0, 1. So right now we are doing for y-axis, so that is why this is our point. So these two are the points. Now how do you find the dr's of the line? You just difference the points, right? You remember the things, okay? I hope one of you remember this. So we have this 0, 1, 0. So this is the dr of the equation. We are trying to find it out. And now we have this point and we have this dr. So what else do we need? We need nothing. So we're just gonna write x minus, it's like the format, I'll just write it first, the format. So this is the formula, right? x1, y1, z1 will be a point, and L, M, N are the dr's. So we have this equation now. We have the point 0, 0, 0. So we have x minus 0, y minus 0, z minus 0. We have this L, M, and N, that is 0, 1, 0. Okay. Every one of you have understood this. So let's suppose it is lambda. So what we get is y is equals to lambda, x is equals to 0, z is equals to 0. This will be our equation. This is the equation of y-axis. This will be our answer. Okay. How did we do it? Origin, common for it, and when we have this y-axis thing, we have this point 0, 1, 0, and then we find out the drs by differentiating the points. Every one of you knows this. And then it was a simple thing, just putting it into the formula, the generalized form, the dr and the point, and we got this answer. Okay. So sorry. Now we have this thing, perpendicular distance from a point to a line. Okay, anyone of you is having doubt, you can text me. You can put it in the comment section. I'll read it out and I'll let you know. Anyone? Okay. So we have this perpendicular distance from a point to a line. So these are the steps. It has no formula. The perpendicular distance thing has no formula. Okay. Perpendicular distance from a point to a line. For example, this is the point, this is the line. So this will be the perpendicular distance. Sorry, my writing is horrible. Okay, so we have this point, okay, and we have this line. Now this is the perpendicular distance. This is the perpendicular distance. Okay, this is the point, this is the line, and this what we need to find. Okay, this is what we needed to find. But this thing does not have a formula. Earlier, whatever I have told you, everything had a formula. Okay, but this thing does not have a formula. It only requires a concept. It is very simple. Once you do 2-3 questions, you will get to know about the concept, and if you will remember this concept, you will get to solve all the questions like that. Okay, all the perpendicular distance questions, foot of perpendicular question. Like in some questions, only perpendicular distance is asked. In some questions, foot of perpendicular is asked, and in some questions, both the things is asked. But it does not create any problem. If you know one thing, you will get to know another thing also, because that's not way too much. So only one concept is needed to be studied, and I'll let you know about it, and you will solve the questions very easily after that. Okay. So here, what is the first step? Find the general point of the line. How do you find the general point of the line? What you do is, you just write the equation which is equals to lambda, and for every x, every y, every z, we get a general point in the form of lambda. Okay, we got this general point. Then find the drs of line joining given point and general point. So then we'll find the drs of the line. Drs of the line, how we'll find it? We have this point, we'll find this point. We'll find this point, which is the general point on the line. So let's suppose this will be the general point. So by differencing these and these points, we get the drs. Okay, that will be the step 2, dr of the line. Now equate the dot product of drs obtained in step 2 with drs of given line to 0, because we have that formula that dot product of any two perpendicular vectors, dot product of those drs will be 0, right? We had that thing. So that is how we're going to solve our purpose, and this will substitute lambda value in general point. Obviously, I already told you the lambda value in general point, and that will give us the value of lambda, and then the value of lambda will give us the point which we needed to find, and after that point we'll obviously find the foot of perpendicular, and if we got the lambda thing, we can find the point, and then from that point to another point we can find the perpendicular distance by 2-point formula. I hope everyone knows it. Under root x2 minus x1 square plus y2 minus y1 square plus z2 minus z2 square, distance formula. Okay, simple thing, distance calculation. Okay, now let's do one question related to it. It is gonna take a little time because I'm going to solve it very slow. So every one of you stay with me, and every one of you will understand me. Obviously, I have told you the steps, so basically we'll follow exactly the same steps. Okay. Okay. Now we have this thing. Find the perpendicular distance from point P 1, 0, 0 to the line x is equals to minus 1 by 2. I'll just write the line first. So we have this line x minus 1 by 2 is equals to y plus 1 by minus 3. Now we have z plus 10 by 8. So this is basically the equation of line which is written in the formula, because it is not written in a proper way. That is why I just wrote it in front of you. Okay, now we just write it like that, and now we can solve. So what is the drs of the line? Drs of this line, it is basically 2 minus 3 comma 8. Now I'll draw the diagram. It will make you visualize things and understand things in a better way. So suppose this is the line, okay, and this is our point, which is 2 minus 3. Okay, this is the dr, of course. Point is 1 minus 1 minus 10. Okay, how do I got to know about the point? X minus x1, y minus y1, z minus z1. Okay, so what is the point? Sorry for the disturbance. So here we have this point, which is 1 comma minus 1 comma minus 10. How it is written? Because it is written as x minus x1, y minus y1, z minus z1. So this is how we just wrote 1 minus 1 and minus 10. Okay, so suppose this is the point. Okay, suppose this is the point 1 minus 1 10, and because these are the drs, so obviously the direction vector will be 2y cap minus 3j cap plus 8k cap. Okay, and now we have this vector. We have to find out this thing. We have to find the foot of perpendicular, which was m. Suppose this is m. We have this point P. What is the point P? 1 comma 0 comma 0. Okay, what we need to find? M. What we need to find? Distance, that is PM. We have to find the PM as well as the M point. If we find out the M point, obviously we can find out PM very easily. So what is our goal? We have to find the point M. Okay, so for finding out the point M, firstly we have to write a general point which is falling on this line. Okay, suppose this is A. Okay, now we have to find out a point which is falling on this line, a generalized point. So suppose this is lambda. Now what will be the x point? 2 lambda plus 1. What will be y point? Minus 3 lambda minus 1. Z point 8 lambda minus 10. Okay, now you got this thing. What is the generalized point of this? So these are the generalized point. Now we assume M as general point. Obviously, if we are taking M, then it is the generalized point. Now we have to find the direction ratios of PM. That is how we are going to find. Okay, step 2. What was the step 2? First step we did generalized point of this vector. Now step 2 will be dr of the perpendicular vector. So how we will find the dr of perpendicular vector? Everyone, PM is perpendicular to AM. So basically PM dot AM what it is? Obviously we have already told you, whenever we use this dot product thing, whenever we find cos theta also, we are only going to use the direction vectors. Okay, so it should not be a confusing thing for you all. Every one of you only has to use the direction vector, which is 2y minus 3j plus 8k. These are the ds, and that is only you are going to use. Okay, now we have this 2y cap minus 3j cap plus 8k cap. So this is the condition, because PM and AM are perpendicular. So we have this PM dot AM is equals to 0. Okay, now this is the condition. Now we have this generalized point, which is 2 lambda plus 1. I just write it in the format 2 lambda plus 1 minus 3 lambda minus 1, 8 lambda minus 10. So this is the generalized point. Okay. Now what we need to find is dr of Pm. Obviously we have written the dr of M. What we need to find is dr of Pm. So how will we find the drs of Pm? See, how we will find out is, we will find out 2 lambda plus 1 minus 3. These are the M point. Now we will just subtract it from the P. So dr of Pm will be 2 lambda plus 1 minus 1. Okay. Again same thing, 3 lambda minus 1, 8 lambda minus 10. What we did here, we used this point P. Using point P, we find out the dr of Pm. We found out the drs of Pm by using point P. We had M point, we had P point, and we find out the drs of Pm. Now we using this dot product. Okay. Now dot product, 2 lambda I cap minus 3 lambda minus 1 j cap plus 8 lambda minus 10 k cap dot 2i cap minus 3j cap plus 8k cap. Doing the dot product, what we got here is 4 lambda plus 9 lambda plus 3 plus 64 lambda, because we have 8 lambda, 8k and kk. Okay, everyone knows how to calculate the dot product, I assume. So I am just writing the theory. 64 lambda minus 80 is equals to 0. So we have 9 plus 4, 13. Okay, now we have 13 plus 64 lambda plus 3 minus 80, that will be minus 77. Now obviously we got here 77 lambda is equals to 77, and we got the value of lambda, which is 1. Now how we find out the general point, which is M? So for the point M, what was the point M? Where it was written. Okay, this is that point which we find out the generalized point, 2 lambda plus 1 minus 3 lambda minus 1. I'll just write it. 2 lambda plus 1 minus 3 lambda minus 1, 8 lambda minus 10. So by substituting the value of lambda, which is 1, what we got here? 3 minus 2. So this is what we got, which is the foot of perpendicular. Now M is the foot of perpendicular, right? What we got? 3 minus 4 minus 2. Let me write it in a clear way. It was easy, the steps. If you draw the diagram, then things will be more clear to you, because you can actually see that which point is occurring on which line and what you have to do. So I will only suggest that draw diagram. Okay, this line diagram is going to help a lot. Okay, so we have this point 3 minus 4 minus 2. This is the foot of perpendicular. You got it. Okay, now what you need to do is find out the PM, find out the distance between it. So what we are going to do is, come on everyone, distance between it. What will be the formula? 3 minus 1 square minus 4 minus 0 square minus 2 minus 0 square. Okay, we got here 3 square plus 4 square plus 4 square. What will be the answer? Under root 24. Okay. This will be the distance formula. Okay, you just subtracted the points and squared it everyone knows it, x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, and we are putting the under root above it. So this will give us the dr of this line. Okay, now what we have here is, everyone of you understood this? So let me just revise this question by these steps. Okay, find the general point on the line. Find the general point on the line. We find out the general point on the line, which was M. We supposedly said that it was the point M, which was supposed to be the foot of the perpendicular. So what we did is, we write lambda in that equation. We find out the values of x, y and z in terms of lambda. So that gave us the generalized point. Okay, we took it as M. Now, what was the second step? Find the drs of the line joining given point and general point. So what we did is, we find out the general point. Now what we need to do is, we found out the drs of this line. Okay, so how we find the drs of this line? Obviously we have a point which is given, we find out the generalized point, we subtract those points and we find out the drs of that line. So we find out the drs of that perpendicular line. Now what is the third step? Equate the dot product. Okay, now what we did was, we find out the drs, we find out the drs. Now it is already said, I have already told you that the perpendicular vectors, the drs, dot product of the drs will be 0. So what we did here, we did the dot product between the drs, we find out the drs of pm. Okay, this was the dr of pm. This was the dr of pm. Okay, and this was the drs of am. Okay, so we did the dot product between them. We did the dot product. See here, pm perpendicular to am. We did the dot product in between them, and we got this answer because everything was known. So lambda was unknown. So by doing the dot product, we got the value of lambda. So when we have this value of lambda, we substituted that. We substituted that in the generalized point, which will give us the point M in numerical format, actual point. So this gave us the M point. Now what it is the foot of perpendicular. It solved the whole question now, foot of perpendicular. Basically in many questions only foot of perpendicular is only asked, and if the distance are then also it is easy. You know the points, you know this point, you know this point. We just did this formula, x2 minus x1 square, y2 minus y1 square, z2 minus z1 square. You use the under root and you got this point. Okay, every one of you have understood this. Now let me just revise everything so that everything will be like crystal clear to you all. So angle between lines done, perfectly done. Perpendicular distance perfectly done. As well as when image of point is known, I know most of you knows the image in x and y axis. Okay, in 2D, okay, I'll just let you know about the 2D way. I'll just give you a brief about it right now, and we'll go to the image thing on our next class. So this is supposedly the graph. If we have a point here, and if it is asked that find the image of the point across y-axis, so what will be the point across y-axis? This. Okay, across y-axis. So what you notice this here, that y point will remain same, y coordinate will remain same. Okay, x coordinate, what will it be? It will be the, if it is negative, then it will become positive, and if it is positive, then it will become negative. Same goes for the point here. If a point is given this, and if an image is asked across x-axis, then it will be here. Okay, and the distance between them, it will be equal. Okay, distance between this will be equal. I hope everyone just imagine it. If you are finding the image across x-axis, then across x-axis, if you see in the words only, I'll just tell you, Across x-axis, x coordinate is going to remain same. Across y-axis, y coordinate is going to remain same. Whatever it is across, the coordinates are going to remain same. And if it is asked across the origin, then you need to add negative to both the coordinates, x and y as well. So this distance and this distance will be equal. So okay, I hope everyone of you knows it already, and if you're not, then I just gave you the brief in the 2D format. And when we will do it in the 3D, then you need to visualize it, because in 3D, if you're gonna draw, then it will make complicate things, like it's gonna complicate things, because obviously you cannot draw actually 3D thing in the 2D, okay? And everyone of you is not an artist. So basically, you will imagine this, we will visualize things, we'll visualize like fingers, you can visualize the corners of your room in the 3D format, and then you can find out the image, okay? We'll use the conceptual things as well. So here, whatever we got started by the angle between the lines. Angle between the lines in 2D format, what you did was use the tan theta format, m1 m2, okay? In parallel thing, m1 is equals to m2, and perpendicular thing, m1 m2 is equals to -1. If not, you know it. In the 3D format, you cannot just find a slope between two lines, because there are 3 lines. So basically, you'll do the dot product thing. In 3D format, whenever angle is asked, because you will do the cos theta thing, and cos theta is equals to the dot product upon magnitude of those vectors. But the vector which will be used will be the direction vectors. Always, there should not be any confusion. The vectors which you will use will be direction vectors. It is the point vector is not related at all. So just ignore that vector and you just use the direction vectors and solve the purpose and get the value of our theta, which is cos inverse of that value. Okay, now subscribe. Obviously, I assume Dishkant Naik. Hello. Hello Dishkant, you are quite late and we are just wrapping it up. I'm just revising. I'm just giving the brief of whatever I have told in the class. So from next time, please be on time and it will be very good for both of us. So yes, now here we have this cos theta. Obviously, I have told you the direction vectors will be used. So let me use another pen color. So this r is equal to a plus lambda, r is equal to lambda b2. So b1 and b2 are the direction vectors, and obviously I have said that b1, b2 direction vectors will be used in cos theta thing. Okay, so we just multiplied b1 dot b2, which is the direction vectors, and divided by the magnitude b1 dot b2. Theta is equal to, obviously it is a cos theta formula, so we just inverse this thing and we'll get the value of theta. Now we did this, find the angle between the pair of lines. Find the angle between the pair of lines given by this vector, this vector. So obviously this vector is not of any use, this point, because it is the point. So this vector will be used. This is the direction vector. This is the direction vector. Okay. So we have b1 and b2. And we just did cos theta is equals to b1 dot b2, b1, same formula, we just use the direction vector. Every time, don't get confused, ignore the point vector, use the direction vector. Next we have this equation. This is a 2D question. We have that point, we have the parallel form of line. So everyone knows that in a parallel form of line, the slope is equal. So we got the value of m. Then we substitute the point and slope and we got the value of c. C is the intercept form. So then we just put it in the generalized form of equation, that is y is equal to mx plus c. We substitute the value of m, we substitute the value of c, and then we got this equation, and this is the answer. Okay. So now next is angle between the lines whose drs are this and this. Dr same thing, we just do the dot product. Angle is asked, do the dot product. Okay. Two lines are parallel. This is the condition. Two lines are parallel. A1 upon A2, B1 upon B2, C1 upon C2. These are the DRs. Okay. Kirti Pawar. Hi Kirti Pawar. I am just wrapping it up. You guys are very late today, and I hope from the next time please be on time. And I'm just wrapping it up. I'm just letting know that whatever I have taught you in this class, so watch it later. Okay, so also let me know how did you like it, put it in the comment section, and if any suggestion you would like to tell me, then you can put it in the comment section. I'll read it on later and I'll execute the ideas of yours. Okay, now dot product, Same thing, two lines are perpendicular, we did this dot product of DRs, which will be equal to 0, and parallel, the ratio will be same. Okay, same thing. Now we have this angle between the lines, we have this line, we have this line. What we're going to use? We're going to use the direction vector. Whenever the angle between the line is r, we're going to use the direction vector. This point vector is useless for us for now when we use the angular vectors. Okay, equation of y-axis. We have this equation of y-axis here. Equation of y-axis. So we need to know 2 points. 0, 0, 0, it is the origin. And if it is y-axis, 0, 1, 0. If it had been x-axis, the point would have been 1, 0, 0. Because it is x-axis, it is 0, 1, 0. I hope everyone knows about it. We find out the drs by subtracting these points. 0, 0, 1, 1 minus 0, 0, 0. This is a dr. Then we're just putting it in the generalized form of equation. And we got our answer. Okay. Now perpendicular distance. I did this whole question in just one page only, and I followed all these steps, and after doing also the question, I repeated all the steps. Okay. Step 1, the line is given. You just find out the generalized point on that. You just find out the generalized point. Now a point is also given. You find out the drs of that line joining. Okay. You find out the dr, and then what you did was just using the dot product property. If the two lines are perpendicular, the dr's dot product will be 0. Okay. Generalized point, dr's of line joining, dr's of the line joining given point. Okay. Equate the dot product of dr's. Dot product of drs. Okay. Now substitute the lambda value, you get the foot of perpendicular. Same thing we did here. What we did here, we had this equation. We find out we had this equation, we had this point, and I just draw the diagram. This was the point. Okay. This was the line. So what we did first, we find out the generalized point form. So for the form we use lambda thing, x, y, z, we find out the point. Okay. Now we have this point, we can find out the dr of this. So drs of pm now, we find out the drs of pm, which is the perpendicular line. We find out the drs of pm. Now what we do is, when we have the perpendicular lines dr, then you will just use the dot product property of it, and you will just do this dot product thing, and that will give you the value of lambda. And the value of lambda will give you the point m. It will give you the point m. Okay. So this is the point m, this is the foot of perpendicular, this is the foot of perpendicular. And if we have the foot of perpendicular, we have these 2 points. Now we have to find the distance. So for the distance thing, you just use this formula, x2 minus x square, y2 minus y1 square, and you just got this answer. This is the answer. This is the answer. Okay. So I hope everyone of you have understood this, and I hope everyone of you have enjoyed this, and I'll try to work hard as well, and I hope you also give me the same response. So see you soon, and every one of you enjoy, and please focus on your career and enjoy your life, but don't get distracted. So I hope everyone does well, and we both will work hard and make us grow each and every day. So that is it for today, and goodbye. So that is it. Bye bye. Bye guys.